welcome to this webinar. Benvenuti. So today we are going to see what it's going to be the new 3D mapping software from KRA. What we are going to see is the release candidate version. I'm Francesco Maffei. I'm responsible for the customer support, for the technical support. Okay. So as you can see, this is, let me switch off my camera so you can see the software in full screen. Okay. First of all, we are talking about K-Framework 3, which is our basic general control software from now on. So from, let's say, the ideal release date of the old software will be end of June. So basically, you will come back on our website, download K-Framework 3, and you will find inside K-Framework 3 also all the mapping tools. So you will have just one software to manage from the project design to the beam steering to the setup of the speakers and amplifiers to controlling the whole system. That's the whole concept. So here we already did the webinars about this part. Basically, this is the part where you have all our products, where you can make the groups, cue, tuning the speakers, etc. Top right, these are, for example, a pair of KH2 with all their options that you already know. Top right, you have the three options. Three of the four options. Three of these you already know are setup, tuning, and network. There is a fourth one, which is the 3D mapping setup. Here we are. So this is the complete 3D environment where you can design whatever you want and do all the things that we will see. Left side, we have sources, list, surfaces, different shapes, and a few tools. So basically all the things that you need to play with are here. Top are basically commands about the interface. Bottom are regarding the audio, all the audio part. Here on the right, we have a properties column that you can open using this button, these two arrows up here. Probably we will make something more clear to open this one. And here you will find all the properties of the object. Let's start trying to design some example, just to show you what we can do. The first basic tool, obviously, it's a square rectangle. Here on the right, you see all the options of it, and obviously the dimensions. The idea is to give you something mainly for live sound where you can design very quickly your venue, your setup, and see the angles that you need for your cluster and calculate the beam steering. So a lot of things have been designed to be easy, quick, fast. Let me close also this one, so it's a little bit faster. Okay, so designing a basic venue can be done just with a rectangle of different dimensions, let's say 20 meters long by 10. We have also another basic shape, which is the trapezoid, is here. So obviously this is the most used, especially if you have to design a venue with seats. Usually they have this shape. So in this case, it's how wide is the first, is the starting point, let's say 15 meters wide. how deep is the room, let's say 20, and what's the width at the end of the venue, and that's it. You can design freely on the software if you have my measurements. If you want, you can just let's show you. You can import an image and draw on it. So in this case, I can take this one. It's just an example, and here I have a dimension that I can use. So I will tell to the software that this line is 43 meters. And here it is. I got my my thing. Here I can decide the opacity of the picture so that I can better draw on it. In this case, let's do an example of a trapezoid. We can put it here, and let's make it 18, maybe something less, 17. The beginning, it could be, I'm just trying 17, also this one, and the top probably would be 20. Yeah, more or less. So very easy. At this point, you have an audience area designed on your picture, and then you can just put the speakers and have the result. Obviously, you can make basic things with the surfaces, like rotate it. So just select the point that you want to use as a center of rotation, and then just move it. The pictures can be used also in vertical. You can rotate it, so you can make a 3D room using the pictures, and then you design on those ones your audience areas, or obviously you can go free by yourself. Another thing is that you can import the 3D files. So you can import the die format files. Die is a standard, a common 3D format that you can export from different software, from CAD, from Vectorworks, from SketchUp, etc. So that's probably the best way to work if you are going to make a complicated design. But let's come back to something quite easy to do. So let's say we want to design a basic venue with a bleacher maybe. So it's 15, 15 wide, it's 25 deep. Okay. There is a snapping option that you can remove if you want. So in this case, I can move it freely. Otherwise, I can move with the snap of 1 meter, or I can change what I want to use as a snap option. Left click is to turn around, right click is to pan, so very easy to use with the mouse. These arrows are moving the object on that only axis. So in this case, I move only on the X axis, Y, and Z. And then these squares are moving the object just in that plane. So in any direction, but remaining on, in this case, on that Z plane. Okay, so let's go back to 0. Then obviously you can add parameters here. This is our venue, our main area. Let's say we have a bleacher, we have a balcony, we have something at the back that goes up. So the balcony tool, it's made to, obviously you can just use a rectangle and put an angle on it, and that's it. If you want to be more precise in your design, you can use this balcony option. So let's move closer. In this case, let's make some example. Here on the right in the properties, we have all the lines of the single, every line that you see here, it corresponds to a line of this structure. So first one, second, third, fourth. They are going from up to down. We are going to reverse this order so that it's easier to understand also visually. So first of all, the venue was 15 meters wide. So this is the, let's say, this is point 1, this is point 2. So basically, this column is the width of the old balcony. As you can see, I can modify every single line, so I can make also asymmetric balconies. We will see how to make it in the advanced mode. But for basic things, this is usually the best. Then we have a first area, let's say, that is 5 meters deep, and it goes up 3 meters, just to make an example. After this, there is a small walkway that it can be like 1 meter, so 6 plus 1. And obviously, it's at the same level. And then we have a second area. Let's say that it's other 5 meters, so 6 plus 5, 11. And it goes up to 6 meters. So this is the standard setup. Two levels of a bleacher, quite easy. Then you can add other lines. So you can make it longer, or you can make it more articulated. Actually, we don't suggest. We suggest always to maintain it anyway quite easy, the design. But if you want, you can make it bigger and longer. Now we have the piece at the end of the room. Just let's do also the left and right. So copy and paste, and here we are. We can rotate it directly from here, directly from this point. If I can take it, no, let's do it from here. So 90 degrees. You can make it with numbers, or you can make it playing from here. And here we are. Okay, obviously this has to be bigger or longer, but we will see later how to make it longer. I want to show you first the corners. The corners can be done in two ways. One is to use the same tool, the balcony tool, and as I said, if you uncheck this one, you go in advanced mode. This means that you can modify every single point of your balcony. So you can make asymmetric balconies, you can make a strange shaped balcony, and obviously you can make also corners. The other way is to use the circle option. So in this case, let's try to do the circle. Here it is. This is born to be a venue by itself as default, but we can make it to be used as a corner. So here is the same. You can have different levels, you can have different points. First of all, it's a 90 degrees angle circle that we need. Then it starts from 0 meters. I mean, it's one single point. We will have to turn this object of like 45 degrees to be able to use it as a corner. Let me mute this one. Okay, so Z45, here we are. Let's put it in place. And then we go to make to copy exactly the same parameters of the bleachers. So these are 6 meters high. We can start one by one. First level is 5 and 3 meters high. So it's 5 and 3 meters. Then we add another one, which is, we said 1 meter, so 6, and same level. And then we have the other one, which is 11 and 6 meters. That's it. So quite easy. We have a corner, we have the two bleachers as we want, and that's the side. Now there is a tool for symmetric rooms, very useful, that just mirror the object. So create a mirror copy, and it's going on the other side of the y axis. So in this case, this was not in the center. Now we will align it, and or just make it longer. Let's do like 16, 16, and 16. Perfect. Okay. We do the same with this one. Create a copy. And in this case, as soon as you did a copy of the object, any modification that we do on one, it's reflected on the other one. In our case, we had to make it longer. We say 25 meters. And as you can see, the one on the right is doing exactly the same things. Let me remove the snapping so we align it perfectly. Okay, done. Let's see the questions. It's always at the moment it's a symmetric on the y-axis. Then in the future it will be able also to do it on the other axis, on the x. But at the moment it's just y. Then obviously, as soon as you copy the object, you can detach it if you need. I mean, if from now on I want to manage this one as a standalone object, detach, and it will come back to be a standalone object. Okay, we did our venue. Let's put some speaker in it. Let's say, first of all, let's put some microphone. Acoustics. Acoustics is where we set a few things, like the SPL and the isomor smoothing. Let's put two microphones. You can put different names. So one can be the venue one, and the other can be the balcony, or whatever. 1 meter high, each one. And then you can place it. Usually I suggest to place it manually wherever we want. We are going to make a few tools to be able to place the microphones in a fastest way. At this moment are completely free, so you can really move it around wherever you want. The idea is to make some tool that goes directly on that surface. Then we can put a stage. We have actually you can import 3D objects, and you can decide to don't make them audience areas. So you can import whatever you want. You can also import if you have a statue, for example, in your area, and you want to get it in the 3D. If you have something that you really want to reproduce here, because it's important for some reason. You can do it using the die format. Talking about a statue in the middle of the square, the software it's working in open air, so it doesn't consider reflections like most part of these kind of softwares. And at the moment, it doesn't consider obstacles, so it's just free air. There is in the plan to have obstacles at least, but it's a long term, so it will be probably in 2 years more or less from now. At the moment, it's just free air, no reflections. Go. Let's put a stage. The stage, okay, this starts with a basic cube. Let's make something smaller, 8 meters by 4, very small stage. Then we can create a surface on top of the stage, an audience surface, so we can simulate audio also on there. At this point, we can put our speakers. We have, at the moment, we have a lot of speakers, and not everything, not all the catalog. They are coming in the next weeks. So we have also the small ones, Domino, Tornado, Lizard, the small truffles, subwoofers from the Azimuth. So this software is usable also to do all the small things, small restaurant project. It's absolutely usable. But let's see the flown array. So Cobra, Python, Cayman, all the portable systems, all the arrays that you can do with those ones. Then obviously the next step is to have also the Mugello. Let's do clusters of Pythons, 4 per side. Okay, here we are. As you can see, there is a pink dot here at the bottom that show you where the cluster is. This cube down here that it's moving together with the 3D, the faces, it's actually a shortcut to some views. So in the case example that I want to see the top view, it brings me to the top view. Obviously, it has to be straight. This is still a bug. And it removes the perspective automatically. So for example, if I want to see the side view of the place, I click on the X here, and automatically I go without the perspective on the side view. Let's come back here. I have my cluster. Let's set up from here, autosplay, and calculate the angles. As you can see, it is quite well detailed, all the 3D part. So can be, we are working now on the best compromise of how many details to show on the software. But you can see nice speakers here. It's possible to take pictures. So it's basically pictures are snapshots of what you are seeing. So now, let's say I took a picture, I want to show this cluster. And these pictures are used later to make a report that we will see. The cluster can do the same thing of the mirroring as the rest of the object. So let's do the other side. Now, done. I already have the frequency response. I already have the angles of my cluster. So more or less all the basics are here. I have all the information that I need, weight of the clusters, the bottom angle, the distance from the ground to the bottom of the cluster, the possibility to change the angles and everything. The hanging points, obviously. Down here, I have frequency range to do the mapping. So we are going to make presets there, but at the moment you go free. So these are tops. Let's consider a range of 408 kilohertz, and I got the mapping. Here on the right, I have the scale of the colors. Moving around with the mouse, I see the SPL at that particular point is that green number top right that is changing. Okay, that's the SPL in flat. Now, if I want to change the colors, auto will make the scale so that nothing is out of range. This software has two colors that are considering the out of range that are really useful if you want to go more in deep in the managing the coverage of the venue. So basically everything that is black is below your minimum SPL. Everything that is white, it's above. So let's the crest factor is these are based on our data sheets. So basically, it's considered with the same ideas, with the same calculation, and we will have, but that's coming at the end. We will have an adjustment, two modes to work because we need an adjustment factor here that will reduce a little bit the SPL. To be able to work also with real amplifiers, because this software is directly connected to the DSP of the speakers. And so we need a little bit of margin. But then it's the SPL that you see on the data sheets, and it's the SPL that you will see on an SPL meter on the field. Now, this is the SPL. If we want to see, example, 85 to 79, okay, this is a range of 6 dB of the scale. So everything that is white is above 85, everything that is black is below. Obviously, this is a little bit more technical view, but it's really useful. Otherwise, auto scale, and they will put the colors so that everything is in the range. There is also an isobar view if needed. Also, this one it's a little bit more technical, but it works absolutely. Good. So these are all the basics. We can add also subwoofers, which are at the moment are arrays. This software, it's able to manage subwoofers arrays, so you can do it automatically. You will calculate the delays and the setup. In this case, we will make something really easy. 3 stacks, 2 subs each one. Yeah, 10 meters wide and 70 degrees. It's something that makes sense. Okay. So I have my 3 subs, my 3 stacks of 3. You can see. Perfect. Let's take another picture that then we will use. So, okay, let's put it here. We take a picture, and it's a picture of the stage. Good. Then, okay, we can redo the mapping, but as we can see in the frequency response, we have the subwoofers now that are doing the job. I mean, usually for live sound, we have this we want this kind of shape for the response. So to go down, 3 or 6 dB per octave. So if we make a full range response like 40 to 8 kilohertz. Update SPL. Could we choose the to suspend them also? You can place the subs wherever you want. At the moment, it's not a problem. There is no hardware to fly the subs, but if you use their bolts, it's absolutely doable. No problem. Okay, so now the subwoofers are louder, obviously, than the columns because it's what we want. So obviously, considering a wide range response, the subs are louder. Let's see just the subs, 40 Hz to 150. And this is what the subwoofers are doing with the delay that it's being set automatically. Then obviously here you can change and adjust it. So these are all the basics. As soon as you've done all your project, let's go back to something more nice to see, and something like this can be good. Okay, we can write down notes if needed, which are these ones. So here you can write down whatever you want. It can be the material list, it can be venue details. It can be, it will be possible to add pictures in here, screenshots. So it can be used to put diagrams, connection diagrams, or particular notes. And then all this together with the rest of the project, let's do this. With the rest of the project, you can export everything. These are the project details, name, venue, and description, reports. So here I can decide what to add: top view, cluster, subwoofer, frequency responses of the microphones. Slideshow are the pictures that we took before, and the notes. And it print out a PDF, basically, that then you can export and send to the customers or bring with you if you are going to set up the system in the venue. Now it's taking a second. It's a little bit slower, basically because I'm sharing the screen and this is compromising a little bit the performances, but it's much faster when it is not in sharing mode. So project name and all the details, and then down here we have all the rest. Position of the clusters, top view to see where the things are, the photos, the screenshots that we took, so the cluster one, the stage, details of the cluster, let's say all the things that you may need, frequency responses, and the notes, that in this case was just a few things written down. Then you can obviously export and save it in PDF. So these are the basics. I want to show you also the beam steering. The software is going to replace completely EASE Focus. So obviously we need also the beam steering, the ABS. At the moment we have the KH7. So let's make a cluster with like 3 KH7. Here we are. And we can put it here. The KH7 are working just with the beam steering, so they are always straight. So obviously, as with the KH8, they don't need any physical angle. Sorry, the KH8 needs physical angle, but they need a beam steering. Absolutely, there is no way to use it without the beam steering. So also in this case, we are trying to make something very easy to use. We make a copy, we make the other side. EBS, it's what we need to calculate the steering. Obviously, if I do a calculation in this way, let's go a little bit higher. This is really too low. Let's do that. Okay. So I have the red thing, the red area, they are basically shooting straight. And that's obviously not what we want. Also reducing the range, we can see it better. So we click EBS. Let's wait a second that you finish the mapping. Okay. We open the EBS page. And here we have the possibility, like on each focus, to decide what's my best setup. What we are trying to reduce as much as possible the options, leaving obviously all the capabilities of the beam steering. But basically, at the moment, we just have these two parameters. So SPL and decay. So it means basically if I want more SPL and less evenness in the coverage, or the opposite. Obviously, if I'm doing, let's say, classical music, probably I can sacrifice some SPL and have the first and the last rows that are listening at the same thing. If I'm doing rock and roll, probably I prefer to have some more SPL and compromising a little bit maybe the evenness of the venue. This is a compromise. Okay. So the starting point is basically compromise. The beam steering is copied automatically between the left and the right. So as soon as I have something mirrored, also the filters of the beam steering are mirrored. Then obviously more things are coming, the selection of the venues, of the areas, the selection of avoidance, if you want it, and all those things that are coming. These on the right are basically numbers that should help you to understand how much you are asking to the system. So if you are reducing a lot the SPL or not, and if you have, for example, side lobes that may be dangerous in indoor areas, or these kind of things. Yeah, there is the idea to make also presets based on the type of event, but then this one will be quite easy to understand also without it. Here we have the green line is the average, and all the other lines are basically a few points around the software took as measurements. So this is after the steering, and this is pre the steering. So as you can see, the differences between the line are huge before and much less after the steering. And the filters are already on board. So basically it's done. As I said, as soon as this software is completed, um, all these parameters will go directly to the speakers. So we don't need anymore to have two software open. It's just you make the clusters here, you make the steering here, and they go to the control area. Okay, here we are. Much better, definitely. Coverage is more even. We ask for something in the middle between the full SPL and the full evenness, and that's it. Done. Easy. So these are all the basics of the software. We have another small thing to show you. Small for probably the everyday use, but absolutely amazing if you are considering in a more wide and professional way. K-Array at the moment is, I think, the only company on the market that has a line array microphone, the KMC50. And obviously a line array microphone needs a software that tell you what you are doing, how to make a cluster of mics and where they are shooting. So in this software, we have also the microphones. We have the possibility to simulate the mics, the KMC50. Microphone array. This is, it's a little bit hard in a venue like this because it's quite big, but we are going to fix it and make it more usable. So 3 microphones in the cluster. Basically, the problem that we have here now is that they are very small. And so it's not easy to identify it, and but we will make it better. So here we have our 3 mics. We can make angles, obviously. So let's do something like, let's do the maximum that we can do. 6 degrees and 6 degrees. Then we have to turn it around. So let's say, okay. Now this is going to be more, okay, as you can see, are very, very small now. So we will make, so here you can give names to things. So it's better to give a name, microphones. They are going to have the same pink dot on the ground to identify where they are, and we will make some tool to be able to see it in a better way. But just to give an idea of what are the possibilities at the moment. So this is a cluster that is shooting on the stage, more or less. We can do, let's go a little bit lower. We can do the mirror copy on the other side. Here it is. So in this way, we simulate what the loudspeakers are doing and where the loudspeakers are shooting. Clicking on this button, we basically flip on the other word. So we can see where the microphones are shooting and how much. Basically, it's an attenuation scale. So we swap here and update. The colors are changing. It's no more a dB SPL, but it's a dB in attenuation. And 1 second, we will see the result. Here on the right, you have the new scale with the new colors. Come on. It's taking some time. Let's see. Let's see if, okay. No, it doesn't want to. It doesn't want to show up to show us the SPL. Let's go back here, and no, it's better. Let's start again with the basic shape. We do this, and okay, and we make just a rectangle, and no, I think it's better if I restart it. These are the problems of the first beta versions. So 1 second, it's going to restart. But I want to show you the microphone. Believe me, it's very interesting what you can do. Okay, here we are. So this is it. The software, as you see, always open in the setup area, and then you can flip here. So let's go back to rectangle. Okay, let's put make it bigger, a little bit bigger, 20, and we can put a speaker going on a side. We can put, let's say, 2 Pythons that are here. Autosplay and mirror, and I got them. And then we put the mics. I like the cluster with 3, with less surfaces. Obviously, it's much easier and faster. And we put the angles that we said before, and rotate it. Okay. Also, the beam is missing on the mic, so it's not easy to understand where the hell they are shooting. And we make the copy, and we swap to the other, and obviously it works. So this is the attenuation of what you can see with the microphones. And if you flip on the other side, this is what the loudspeakers are doing. We are going to make this passage quicker so that you can even overlap the two things. But it's very useful, especially for orchestra gigs, special kind of events where you want to be sure that the two things are not interacting too much, because obviously it's always an issue. So let's just as satisfaction go back on this one. Also here you can adapt the scale and change the levels and use the ISO bars, etc. So thanks to you guys, a lot of people from all around the world, I see. So there are more to come in the next days. If you want to invite other people, and then Daniele Mocchi has other events coming for June. Soon it will be available on the website.